Hello AP Stats, this is Mrs. Harding. This video goes along with lesson 11-2C. This is the last video for chapter 11. And basically what we're going to cover is just some additional analysis of these tests for homogeneity, tests for independence that we've conducted. So at the top of the activity, you will recognize this two-way table. This was an experiment done where different music was played in a wine shop, and then recorded was how many bottles of each type of wine were sold given a type of music that was played. In activity 11-2A, we did a test for homogeneity. We did find there was significant differences among the distributions of the wines that were purchased under each of those three music conditions. But in addition to rejecting the null hypothesis and stating that the evidence supports a difference, we're going to add to that analysis and look at specifically what values were contributing the most or what was significantly different. And underneath this, there is Minitab output for the test that we completed. So remember what's all in Minitab here. There is the observed count, the expected count, and then the chi-square contribution underneath. So in here, you can see that these two cells right here that were circled are contributing the most to the chi-square test statistic. If you look above each of them, so here when French music was played, we observed only one person buying Italian wine. We would have expected about 9.5 to do that. So this was significantly less of what actually happened than what we would have expected. And over here, when Italian wine was playing, we observed 19 people buying Italian wine. We would have expected only 10.72. So this, the observed value, is actually much greater than what we would have expected. So these two are contributing the most to our test statistic, which remember is making that test statistic, struggling with that one, further to the right, which eventually gives us a smaller p-value. So how would we add that into our conclusion? You can take a look here what's written, but we know that if there is no difference in the proportions of wine types purchased when different music is played, those values right there are the most different than what we would have expected. We would have expected more people to buy the Italian wine when French music was playing and less when Italian music was playing. So those two values are contributing the most or making them have the biggest difference from what we would have expected. Underneath this, there is just a word of caution there. When we are doing this test for homogeneity, the null hypothesis is always that there's no difference in the population distribution. And the alternative hypothesis is just that something is different. You don't want to state there that all of the cells are different or all the expected values are different. Sorry, the observed values are different. So we're not going to say all the distributions differ. It's just that some differ. This is actually a common mistake on the exam. So just keep an eye out for that. Don't say that all of them are different, just that some of them are different. Some of these proportions are not the same. Okay, now that we've completed these tests, I want you to think about something for a second. If we only want to compare two proportions, we actually now have two different ways to do that. We were comparing two proportions back in chapter 10 when we did the difference of two proportions. And now we could also apply a chi-square test for homogeneity just based on a 2-by-2 table, which would then lead you to 1 degree of freedom. In both of those cases, the null hypothesis is that the distribution of proportions is the same, or P1 is equal to P2. And the alternate is for the two-sample z-test is that P1 is not equal to P2. And the same there for the chi-square test. That's the equivalent of saying that the proportions are not equal. So when the conditions are met, these two tests give the same p-value. So whether you run a two-sample z-test or if you do a chi-square test for homogeneity, you will get the same p-value. And one thing to think about is that, in fact, the chi-square statistic is just the square of the two-sample z statistic. And we'll look through this in a second. One thing to note, though, is you cannot use a chi-square test for a one-sided alternative hypothesis. You can only do it for a test of no difference because that's what the chi-square test does, that the proportions are different. So if you flip to the next page, there's an example there about shopping at secondhand stores. It says shopping at secondhand stores is becoming more popular and has even attracted the attention of business schools. A study of customers' attitudes towards secondhand stores interviewed separate random samples of shoppers in 2 secondhand stores at the same chain in 2 cities. The table is shown below, broken down by gender. So you can see we have a two-way table here. The cities broken down by men who shop at secondhand stores and women who shop at secondhand stores. And then the question is there a difference in the proportion of women who shop at secondhand stores from these 2 cities? All right, well, we could do a chi-square test of homogeneity for these 2 populations. This is a 2 by 2. If we did that, you can take a look at the Minitab output here. There's the observed count, there is the expected count, there's the contribution to the chi-square statistic. And then down there, our chi-square statistic is 15.334, degrees of freedom is 1. We end up with a p-value that's essentially 0. So what conclusion would you draw? You would say that there is evidence of a difference in the proportions of men and women shopping at secondhand stores in these 2 cities. Now when you look on the next page, if instead we had decided to do a 2-sample z-test for the difference in the proportions of women that shop at secondhand stores in these 2 cities, you can see the results of this test. You can see in here down at the bottom the z-score 3.916, the p-value is again 0. So what conclusion would you draw? We would draw the same conclusion, that they differ. There are different proportions of women who shop at secondhand stores in City 1 than there is in City 2. Now the interesting thing here is take a look at C. It says verify that the chi-square statistic is actually the square of the 2-sample z statistic, and you should find that 3.916 squared is the same as our chi-square statistic. You can also go to your calculator and verify that the p-values are exactly the same. Now, it's not necessarily clear from the 2 Minitab outputs because both were essentially 0, but if you do these CDFs on your calculator, you will see that both of them are 9 times 10 to the negative 5th. Take note in here that when you're doing the 2-sample z-test, when you find the area under the normal curve, because this is a 2-sided hypothesis test, you have to take the area times 2. But you see that you get exactly the same p-value. Go ahead and scroll to the next page and pause the video. I want you to try out the check your understanding that you see on the next page. Okay, so you should have checked your answer to this question. Was this an experiment or observational study? This was an experiment. The treatment was how the question was asked. Putting together the 2-way table with the observed counts and the expected counts is there. And so for part C, are the differences between the 3 groups statistically significant? Give appropriate evidence to support your answer. This is our test of significance. So the null hypothesis is that there's no difference in the proportion, and the alternate is that there is a difference in the proportions of people that would say yes to cocaine use based on how they were asked. So to go through this test, we need to check our conditions. All of the expected counts are at least 5. Remember, you do need to indicate those in your work. Random assignment of treatments is stated. Independence between and within the 3 treatment groups is just a little bit unclear. So you may have said in there that due to random assignments, they are independent. It's a little bit more unclear than that. And then you take your chi-square statistic. Remember, you can use your calculator functions on these. You end up with a chi-square statistic of 10.62, 2 degrees of freedom, and a p-value that's 0.0049. So what conclusion are we going to draw? Reject the null hypothesis and conclude that there is evidence of a difference in the proportions of people that say yes to cocaine use based on how they were asked. As always, if you have questions, please let me or Mr. Bowman know. Have a nice day.